Now things are going to get more interesting as we dive into my favorite topic, DC coupled systems. This is a residential DC coupled system with a backup loads panel. Let's start with the solar panels. The PV is typically 300 to 600 volts DC for a residential system and can be connected to a DC to DC converter, or sometimes called a solar converter, or sometimes called a charge controller, or sometimes called a solar charger. This device converts the PV voltage up or down to the battery voltage to properly charge the batteries. This point after the charge controller is called the DC bus, and where the DC coupling is happening. The PV typically will charge the batteries first, and then any excess will go to the inverters. From there, the inverter can deliver power to both AC panels, and if there's any excess after that, it can export to the grid, if you're allowed. At night, the inverter's charger can charge the batteries from the grid. So we're coupling two sources, solar and the batteries via DC power on the DC bus. What exactly the inverter does is dependent on what its use case is or application. What goals is the system trying to achieve, and what is its priorities? This can be programmed directly into the inverter if it has the capability, or an external controller. Now, that would be a whole nother series, and if that's something you're interested in, please let me know in the comments below. Now, what happens when there's an outage? The inverter does not export to the main panel, as that could backfeed the grid during the outage. So, only the backup panel is powered in this type of system. FYI, inverters tend to now have the charge controller already built in, eliminating the external unit altogether. So you would attach your PV and batteries directly into the inverter, kind of like my solar converter that I have in my home. There is another similar configuration that does not involve a backup panel at all, but instead a loads manager. The inverter has a dedicated input to the grid and a dedicated input to the AC panel for the home. The home can be powered by via solar, batteries, grid, or a combination of all three. During a solar day, the PV will provide power to the AC panel, possibly charging the batteries if needed, and if there's still excess power, it can export out to the grid. When there is grid power available in this example, the power from the grid can be passed through the inverter to the AC panel, if there isn't enough PV power. When the grid goes out, the PV and batteries may still power the AC panel if they are not sized to provide the full backup. Then the non-essential loads are removed via a relay with a loads manager panel. And I actually have this type of configuration in my home with a solar converter and a lumen panel. So the lumen panel is what I use. In the next video, we're going to talk about AC coupled PV systems with PV plus storage DC coupled systems retrofit. It is getting more and more and more complicated, but it is a lot of fun. I'll see you in the next video.